Hey guys, this is the last part in our Unit 6 recap of all things energy. Now, these are all renewable energy sources. So, moving forward with this, remember again, I always want you to take a look at the course and exam description, stuff that you need to know before you move on. Also, keep in mind the same stuff that that we talked about with non-renewable energy sources, which is look for the areas of pollution, especially in the processes that come before and after it does whatever it does. The one thing that you also have to look at with renewable energy that you don't have to look at with non-renewable energy is how much energy can you get out of this and at what times of day is it available. A lot of forms of renewable energy that produce electricity are not going to be available to you 24/7. So the question becomes, what do you do when it's not available? And the answer is honestly pretty simple, and it's twofold. The first one is you design ways to store that electrical energy, and that would be in battery technology. Before we had all of our shutdowns, I do know that people like Elon Musk were working on ways to store energy in large batteries. Like I want to say that he had created one for a home, which if you used it with something like, let's say, solar paneled shingles on your home, you would have a system that would where you could store up a lot of energy during the day and then go ahead and be able to use it during night. So that's one of the two solutions to the question of, well, this isn't available all the time. The second answer to this question is that you create a energy grid. And again, when I say energy, I'm largely talking about electricity. You create an electrical grid for your town, for your city, so that it's drawing from more than one source. So, do I personally think that there is going to be a time in our lifetime where we're going to be able to walk away from non-renewables? Probably not. But could we possibly make a grid where we get some of our energy from burning biomass, some of our energy from solar, some of it from wind, some of it from hydroelectric? Absolutely. We would just need to make a grid that would pull from multiple resources. Now, the advantages to that are that you have, obviously, you're creating jobs. You are switching towards things, as we're going to see, oftentimes create less pollution or are more sustainable because you're drawing from things that are either perpetual or renewable. They're not going to run out on you. But then also from a homeland security perspective, if we're really concerned about keeping our country secure, having power running all the time is kind of vital. I'm sure, being citizens of the state of Florida, that you are familiar with what it's like to lose power more than once during a hurricane. It basically brings everything to a grinding halt. Wouldn't it be nice to have a grid that if somebody were to, say, invade our country and they took out the coal-fired power plant, we would still have waste to energy, we would still have solar, we would still have wind, we would still have hydroelectric or tidal to pull from. It would make those grids what's called decentralized, and that you just don't have one power source to draw from. It's a way of making towns and cities more secure in terms of their power resource. And also, quite frankly, during a hurricane, obviously everything has to shut down during the storm, but it would mean that solar power aspect would be available immediately. I don't know if you guys caught this during the non-renewable recap, but it can take almost a full day for a coal-fired or a natural gas-fired power plant to come back online. So it would actually help places in disasters to come online more quickly. So again, none of these is going to be a non-renewable replacement if you're talking about powering an entire city. However, there are ways to make this work, and it's just something we have to think about and commit to if this is something we want to do. All right, so let's go ahead and get started. As always, please make sure you pause and take a minute to look at these course and exam description pieces. You're going to want to make sure that you pay attention to this stuff. In Unit 7, I haven't looked at the slides again. I probably haven't put this in there, but you've got a copy of that course and exam description in the documents that you have on Canvas. All right, so we're going to talk about biomass first. Remember, again, biomass is stuff like wood and charcoal largely, but it's anything that you get from plant growth. So that also includes animal dung. It includes things like paper. Any of that's crop residue, and by crop residue I mean the parts of the plant that you don't want after you harvest the stuff that you want. All right, so, oh good, I did actually write all of this. And again, garbage falls into this as well. Municipal solid waste, because this is not on the test, let me define that for you. Municipal means for a city, solid, and then waste. So solid waste is garbage. So municipal solid waste basically means your city's or your town's garbage. And then also this includes biofuels, which obviously you don't get directly from the ground, but you can create those from fermentation. Okay, so biomass, again, is most often used in, first of all, in developing countries, and then secondly, straight up for heat and light. You burn it, you get what you need from it right there. But you can use it the same way that you use coal and the atom. You burn it to boil water, to create the steam, to turn the turbine, to turn the generator, to create the electricity. Now again, we are not going to get to, for the national exam, solid waste, but let me go ahead and just briefly talk about it, because I did talk about this when we talked about soil. Landfills, sanitary landfills in the United States are built so that they have a clay liner and a plastic liner. You take your garbage, you put a layer in, you pack it down as tight as you can, put some dirt, layer, pack it down, dirt, and then when it's full, you cap it with another layer of clay and then soil and then grass or some other greenery. So basically, in the developed countries and in the United States, our garbage is packed so tightly that very little decomp takes place. And when we talk after the national exam about garbage, I will talk about that then. But here's the deal. We're creating these Tupperware containers of our garbage. Now, how do we reduce that? First of all, we should be making less garbage, but that's a talk for another day. So what can we do right now? And here is the answer that you're looking at, and this is where I'm coming back to the slide. What you are looking at there is a waste-to-energy plant. I live in Lee County, and we have one of these there. They are not very common, but we have one in Lee County. And basically, here's what happens. You take a portion, if not all of your garbage, to this facility, and it's sorted. So hazardous waste goes to special landfills that keep it segregated from nature for like forever. And that's things like batteries and all of that, which you shouldn't be throwing away in the first place. Things that can be recycled. Glass and metal are separated. While that's the right thing to do, it's also a way to defray the cost of all of this sorting that has to happen at the waste-to-energy plant. So that stuff is sold to bring money in to offset the cost of the sorting that has to happen. And then everything that's left that you can burn, paper, wood, food scraps, anything that is organic, you burn it. And when you burn it, you create, again, the heat, da-da-da-da. Now you have the same issues here that you have in a coal-fired power plant. So look for the sources of waste. You are still creating solid waste here. But what I will tell you is, any metal stuff that you didn't pick up over here, that can be taken off and recycled. When you are burning things that are organic, that don't have the impurities in them that say that coal does, the mercury and all of that other good stuff, Yes, I know mercury and whatnot can still get caught up in there, but it's at a much lower level than you find in coal. You can then take this ash and I have the tree on here. You have to be really careful growing things because whatever's in the soil is going to end up in the tree. So anyway, it's still going to be safer than that coal ash, which is why it's ending up in a regular landfill instead of to a secure landfill. And then what this aggregate here is again, that's probably going to go to a secure landfill. All right, so my whole point is, sorry, I changed thought midstream, is the stuff that you're taking to a landfill here is still less than you would have taken to a landfill over here. So you're still creating solid waste, but it is by volume a lot less than it was that you started with. You are going to still have carbon dioxide that's produced. You're still going to have, whatever other pollutants. But again, you just, as we're going to talk about in the final bits of Unit 7, there are filters, just like filters on a cigarette, that help to get rid of a lot of that. And quite frankly, these are much better than the filters on the cigarette because this actually gets the majority of air pollutants out of there. Please, I am not condoning smoking. It's still terrible for you. The reason I don't have as much problem with combustion is the way that we store garbage here in the United States promotes anaerobic combustion, which produces methane. Methane is a greenhouse gas that is stronger, for reasons you don't know right now, than carbon dioxide, so I'm actually kind of fine with this. And considering that you're burning things that are plant-based to start with, it could be argued that the carbon dioxide that you are producing is no greater in volume than the carbon dioxide that was absorbed by this stuff in the first place. All right, so anyway, so you have acknowledged this and this. Now, what you don't have over here is any of the mining stuff that happens. Now, that doesn't mean there is no pollution in the formation of the garbage because, again, think about all the things that go in there and think about all the processes that create that. But considering the humans are creating that in the first place instead of taking this to a landfill where it does nothing, here it's serving a purpose. So look at the rest of the process. This looks exactly like what you see in coal-fired power plants. So again, this is where biomass is being used in a waste-to-energy plant to create electricity. All right. If you grow biomass specifically to do things like make biofuels, the argument can be made that this is a close to carbon neutral creation because plants take in carbon dioxide. You're creating the biofuel, which is then burned by cars, which emits the carbon dioxide, which is then absorbed by the plant. Of course, they're leaving some stuff out, which is these guys create carbon dioxide. This also creates carbon monoxide. So this is not a completely closed system, but they do have a point here. Your carbon footprint overall is going to be lower than it is with coal because coal is a carbon sink. It was never intended to really enter back into the carbon cycle to start with. Every single day there are things that die that end up being pulled into the earth, going through that anaerobic process that creates more coal. So that's we are not taking away from that basically carbon savings. So while this isn't perfect, it's definitely better than growing than mining coal. Now again, notice there's still a problem here. You have a loss of biodiversity because this is a monoculture, and you also are destroying habitat by creating these fields. But again, you have those offsets. Now, also realize most cars right now in the United States are not built to burn strictly biofuels, so that is another barrier here in the United States to doing this. Okay, so again, this is what I was talking about. Fossil carbon is supposed to be there. We're supposed to be taking part of the carbon that we create and storing it here. There should be a fast part and a slow part. So, yeah, this is all just what I just said. All right. Now, this is also really cool. There is a company called Alginol in Lee County that is actually doing this. There is algae that creates an oil um, that can be used as biodiesel, and then you can take the algae itself and ferment it to create bioethanol. So if that is something that is fascinating to you, you can make an entire career out of growing algae to make biofuels. All right, so please also realize you can use corn, sugar cane right here, and something called switchgrass to create ethanol, which is another specific biofuel. If that word ethanol sounds familiar, that is the alcohol part of alcohol that makes it alcohol, drinking alcohol. The reason I have switchgrass on here is that this is a kind of grass that grows incredibly quickly, meaning that you can harvest it multiple times a year and use that biomass. It not only grows quickly, but it grows densely, so you get a lot of biomass per unit area when you're growing stuff. Take a look at how this process works. Currently, we use ethanol in the United States. I believe it's up to 10% to make the gas supply stretch further. So if you have a gallon of gas, you will add 10% of a gallon of ethanol to it. That's how much ethanol our engines can handle before they start not working so hot. Brazil is a country that currently has ethanol only powered cars. So why don't we do that? Because we don't. Okay, so recognize the ways that biomass can be used straight up as a source of power, and then also how you can, the different ways, waste to energy plants, biodiesel, algae-based biofuels, and then straight up ethanol. Also, please understand that how do you get that ethanol? It's fermentation. Fermentation is a anaerobic process. All right, solar power. This is, where is solar power a good idea to use? This right here kind of tells you where it would be a good idea to use it. Okay, so there are many ways that you can use solar power. One is called passive solar heating. You can literally use, let's go back. You can literally use the sun to cook your food. Now imagine how revolutionary this would be in countries where they use biomass in order to cook things. Now, this is a slow process. It takes all day. But, I mean, here in the United States we have crock pots, same idea, slow and long. Imagine what it would be like on a sunny day to go ahead and set up your pot and not have to go collect that firewood to cook your meal at the end of the day. Now, is this perfect? No, this requires foresight. You have a sudden shower or whatnot, it's not going to work for you anymore. But the pros are, on the days that you know it's going to be sunny, heck, you don't have to go get firewood, or the firewood that you do use will be stored against the days that maybe you are too ill or too tired to go get it that day. We can use passive solar heating here in the United States to help heat our homes. Now, here in Florida, that's not a concern, but think about up north. If you have windows that face, well, actually, we can use south-facing windows here in Florida. I'll get to that in a second. So, dark roofs. You paint your roof dark in northern areas. It helps to heat your home. It's one of the reasons why here in Florida, it's a really good idea to have a light roof, because it will literally cut down on your air conditioning, because you're reflecting the sun. Because remember, light roofs and things that are reflective like this have what's called a high albedo. They don't absorb the sun. South-facing windows actually work for cooling as well as heating, like this. When windows face the south in the United States, it gathers all of the sun in the wintertime, because in the wintertime the sun is low in the sky. In the summertime, the sun spends a lot of time up high in the sky, meaning you don't get as much of that direct sunlight. meaning that you don't have to combat that to cool your house. Now, why don't we do this here in the United States? Because especially in, well, actually pretty much everywhere, people like their houses to face the street. In order for this to work, you would have to be comfortable with the windows in your house, the majority of the windows of your house facing whichever way the south is. So also, how does this work? Let me explain these two things here. Heat absorbing surface. This also will only work if you've actually got a surface to absorb it. So instead of carpet, you would need dark colored tile as an example that would absorb this during the day and release it at night. Or if you had pipes of water circulating through, they could then help to circulate that through the house if you had those pipes going through your house. And then thermal mass. Your walls and floors need to be built extra thick so that they, like a thermos, keeps the hot things hot and the cold things cold. So when you have all this heat coming in, if your house is super insulated, it means that you are keeping that heat in your house. And then it also means that if your house is super insulated and it's cool in the morning, it will remain cool and it will keep the heat outside of your house. Basically, it's just a barrier to heat flow. That's all it is. So why don't we do this? Again, there are some cultural reasons that we don't do this. And then also remember there is an initial cost in building a house that is super insulated. But again, I am sure that there is someone out there who can come up with a cheap but strong and effective way of super insulating our houses. Okay, then you have something called active solar heating. Notice that with both passive solar heating and active solar heating, we are not talking about electricity. Active solar heating is more of what I was referring to with the pipes going through this. Passive solar heating is strictly the structure of your house, gives you what you need. Active solar heating means that you've got a series of pumps and pipes of water that run water up to these dark panels. This is not a solar panel. This is an active solar heating system. So you pump your water up here, it gets hot, excuse me, and then you pump it through the house so that it releases the heat in your house. Here in Florida, people use this system to heat their pool rather than using electricity. I mean, why not? Because you're using less energy for the pump than you would be to than to be using electricity to heat a coil to then heat the water in your pool. So what people will do, let's say this is a pool, they will pull some of the water up, heat it, and then pump it back down into their pool to heat it up. So again, we're still not talking about electricity. Passive solar heating is just the structure of the house and the way it faces. Active solar heating is where you use a pump and a system of pipes with water in it to either heat your house or heat the water that you use for your shower or heat your pool. You can also use the sun's energy in an indirect fashion. So here's what you do. You have a tower that has a receiver in it that has a liquid that boils at a lower temperature, like let's say water. Not water, excuse me, like alcohol boils at a lower temperature than water. And then you have a whole bunch of mirrors that they're called the heliostats. They basically follow the sun, so they take the sun's energy and they reflect it, so it all concentrates on here to boil that substance to make steam or to make a vapor. Steam is particular to water, by the way. To turn the turbine, to turn the generator to create the electricity. So here they're happen to be using water. You can also use a liquid that boils at a lower temperature, in which case it would be vapor and not steam. Alright, so let me go overhead pros and cons. The pros to this are, again, you're using electricity to make this happen. The cons are you have the initial startup, and then also if you're in a place that's not very sunny, this doesn't work for you. Same deal here. Pros are sun's happening anyway, why not use it? Cons are obviously habitat destruction, loss of biodiversity. If you have these are powered by a motor, You would have to then use energy to do that. You have whatever energy and fossil fuels are used to build these mirrors in the first place. If the mirrors get pitted or break, they have to be replaced. This only works in sunny areas, obviously. Now, in terms of habitat destruction, again, it's not as much as a coal plant. You've also got the rows in between here, and things can and do learn to live there. Creation of new jobs is another pro. Any of these are creation of new jobs, because not only do you have to build this, you then have to maintain it. You then have to jack this into the system that you already have. There's lots of opportunities to be employed with something like this. All right, now, this is what people think about with solar panels, with solar power, is panels that create electricity. And this is the sun creates electricity. There's no turbine, there's no generator. So, how does this work? The photovoltaic cells are built with a N-type layer and a P-type layer. They're semiconductors, which means that they are made of metalloids, like silicon. So how does this work? The N-type layer is the negative terminal, the P-type layer is the positive terminal. The energy from the sun knocks electrons from one layer to the other, creating the electron flow that creates the electricity. This process, I am not sure whether or not you need to understand it in more depth than that. It'll just be one of the things that we'll put onto our cheat sheet so it's there for you. Now, pros are, here, no emissions, no moving parts, it just does its thing. It can produce electricity during peak demand. Imagine, one of the sunniest days, those are also the days that you need the most air conditioning here in Florida, for example. It's economically feasible. Once you pay it back, which doesn't, in the scheme of things, take very long, it's pretty much free. It can be used on a small scale. People here in Florida who have these things on their roofs, in general, make more electricity they can use in a single day, and they literally sell the excess electricity back to the power company. Also, imagine how this would work in developed countries. You could have single huts have these on top of their homes, and they could use that electricity to then cook instead of using power plants. What if you're a diabetic in the middle of a developing country? Now you have a solar panel that could be used in part to power a refrigerator to keep your insulin cold, or it can keep vaccines or medications cold. You can use it to, in part, keep your food from spoiling. If you combine that solar panel with a battery, you could theoretically use it 24/7. So I don't know if you guys have seen like the parking passes that are given at the beach, which really kind of only need during the day. They're largely powered by solar panels now. So it just means that you can take something that requires electricity and plop it down in the middle of the day. I mean, solar panels, I have a portable one that I take with me when I go on hikes, because then it means that I always have a source of energy for my phone. It can be used for kids to charge a battery, so then battery-powered lantern, so then at night they can do their homework. It can be used to power laptops in places where you can put Wi-Fi up, but you can't put up a power plant. I mean, solar panels to me can be very liberating. It provides energy on the smallest of scales. Okay, drawbacks are that it's an expense. With less solar radiation, payback can take longer, so if you're in an area that doesn't get sun every day, that's problematic. And again, the manufacturing process has its own drawbacks. And then the other issue is it does produce DC power. Here in the United States, we use AC. So again, how do I use that panel when I go hiking? There is a little conversion that makes sure that I can use it with my phone. Okay, hydroelectric power. So this is the classic example. You have a large dam. We've already talked about what this does in terms of, well, we'll get to the pros and cons here in a minute. Okay, first of all, you have run of river. It is, you have a very low dam. You have no reservoir. What are the pros? Little flooding. The river flow is not as disruptive. The cons are this is smaller and unpredictable. So this is a perfect solution for, let's say, a ranch in the middle of nowhere, or maybe for agricultural systems. So this electricity can be used to power drip irrigation. So this is very good for smaller applications. But if you have a lot of smaller places along a river, maybe this is a better idea than actually damming up the whole thing with one dam. Because again, look at what this is not doing. This is not blocking the flow of the water, not only for environmental purposes, but then also for the people who live downstream. They can still depend upon that water. Side note, as a reminder, the amount of water that's in a river really depends upon the season. There are different seasons where you have more water present than others, because remember, it depends upon rainfall and snowpacks melting and stuff like that. Okay, so water impoundment. These are the big boys. The one that has the largest reservoir in the world is in Washington. The largest dam in the world is the Three Gorges Dam, which blocks off the Yangtze River in China. This one is, back in the day when we had multiple choice, that would have been one for you to know. It's just something to kind of keep in mind. Okay, so then you also have tidal systems. So we'll get to pros and cons again here in just a second. So you've got a turbine that moves both ways, so you can take advantage of the tide coming in and the tide going out. Okay, so these are efficient, but tidal differences are not super great. The con of using tidal power, by the way, is just that you have there aren't a lot of places where the tide is strong enough to actually be worth building, but that doesn't mean they're not a solution in some places. If you can't tell, renewable energy is about, kind of like integrated pest management with farming, is about finding the best solution for where you are. There's no one size fits all for this stuff. So let's revisit dams again, pros and cons. Definitely take a look at all of this stuff. Realize whenever you talk about things like recreation and fishing, you also have an opportunity for employment here, and then also the building and the maintenance of the dam is also a opportunity for employment. So pause at this slide and make sure you've got all this stuff. But let's go ahead and talk about how this actually happens. Okay, you have how you get electricity from a traditional dam. You have a reservoir, you have the dam, which is just a wall. Water goes in. This is a reduced intake, and just like you putting your finger over a running hose outside to make the water squirt faster and farther, when a large source of water narrows to a smaller intake, you speed it up. That turns the turbine. The powerhouse is the generator that turns the generator that creates the electricity. So notice what's missing: the burning of stuff to boil water. So while this water is warmer when it comes out than it is over here, just through the mechanical agitation, you do not have thermal pollution. What you also don't have here is air pollution. The only air pollution that is associated with a dam is in the construction of it, and then any decomp that happens of stuff that's blocked behind it. So again, there is no free lunch, but it's definitely a quote-unquote cleaner source of energy than than any of the fossil fuels. Remember again, what happens when you have a series of really of these big dams is eventually you don't have a whole lot of water ending up at the very end, which is bad from a environmental perspective, because remember, at the mouth of every river is where you have an estuary. Go back and look at how important those are. And then it also means that the people downstream are like, where's my water, bro? They don't have it for residential uses, and then they don't have it for industrial uses, and they don't have it for agricultural uses. So, again, pros and cons as far as the eye can see. And we had already talked about fish ladders, so you know how to mitigate problems with fish migration. So, here is the deal with the Three Gorges Dam. It is 2 kilometers long, and as a reminder, as I am looking up a conversion factor, let me remind you as to how long that is. Kilometers to miles. 1 kilometer is 0.621 miles, so that means that 2 kilometers is about 1.25 miles. So if you can walk 1 mile in 15 minutes, it means that if you walk for 17 or 18 minutes, that's how long that dam is. So the pros are how much power this thing puts out and the kind of air pollution it's replacing. The cons are it displaced a lot of people, because remember that you have flooding that now occurs back here, so all of the land folks used to live on near the river, gone. This is also a small problem right here. The dam's built over should say seismic, not seismatic. Remember, a seismic fault is where 2 tectonic plates are moving against each other. So, gee, what might happen if that breaks? All that water gets released all at once. And remember again that you have sediment built up back here. That means that you're not getting it downstream. You also have water building up back here. That means you're not getting it downstream. So riparian zones that were up here get flooded. Organisms that depend upon that sediment downstream don't get what they need anymore. Estuaries suffer. So please make sure, again, you see the pros and cons in all of this. A lot of dams are being removed as we move to other renewable energy sources. Obviously, it's better for the environment if they're not built in the first place, because everything serves a purpose, or it wouldn't be there in the first place. Evolution would have gotten rid of it if it no longer serves a purpose. Yes, when you remove a dam, people freak out because of the flooding that happens, and the river changes its course, and it's like, that's what it's supposed to do. It definitely makes the environment more stable, because all of the systems that were set up in place, from riparian zones to the food web of biodiversity that's in that area, become stable, because all of the things that they were built around come back when the water is allowed to flow where it's supposed to be. Alright, so again, benefit of dam removal. If you're wondering why salmon looks like this is salmon's, just useless fact here, salmon's entire jaw structure changes as they make that migration back to their hatching grounds to lay their eggs and deposit their sperm and die. If you think that that's fascinating, I encourage you to pursue that via YouTube. And then again, the potential issues of dam removal. Take a minute to read all of this. On the national exam, I am betting that you're going to get a make a claim and justify. There is no wrong side to how you land on these things. Should we take all dams down? I don't know. There are 2 ways to go about this. No, leave them in place, because you have, again, that legacy sediment. You have all of the new biodiversity that has arisen based on the new way that the river is. Human structures, and we depend upon this type of energy that does not create air pollution. However, again, ecological systems are built to be the way that they are. Evolution takes care of that. There is no way of knowing how much stress we are putting on other systems in other places because we don't have rivers flowing the way that they should. So, pros and cons. And you should be able to support your claim on actual evidence and not on feeling. Okay, geothermal energy, make sure you read this. There are a lot of different ways we can use geothermal energy, so we're going to talk about how you do it with to create electricity. There are two ways that you can do this. The first one is you have a pocket of magma really close to the surface, so you pump water down and the magma boils the water that creates the steam that turns the turbine, that turns the generator, that creates the electricity. Or there are naturally occurring pockets of steam that you then direct to turn the turbine, to turn the generator, to create the electricity. You still need other sources of water in place, and this is true of any time that you are turning a turbine or turning a generator. That mechanical force creates its own heat through friction. You got to cool that down so it doesn't overheat and stop working. This one doesn't include the cooling aspects, but you do have to, there is a little bit of freshwater use there. So what are you not doing? You are not burning anything. You are not creating any air pollution. This right here is just steam, H2O. Great, go, have fun. So this is beyond the habitat destruction and the loss of biodiversity and then the fossil fuels that are used to build these plants. This is a largely pollution-free way of creating electricity. Now, of course, there are cons. And the cons are, unless you have that bubble of magma that's really close to the surface, you can't do this. In the same way that with hydroelectricity, you can't use a river if you don't have one, you can't use these bubbles of magma unless you have them as well. Now, realize there is a different way to think about geothermal energy, and that is simply the earth. So please realize that these are different. When you're talking about using geothermal energy to create electricity, you're specifically talking about these steam pockets or these magma pockets. When you're talking about heating or cooling a home, you're just talking about the ground. The ground stays at a constant temperature all year. So if it is the winter time and it is really, really cold and the earth is warmer, if you pump the air in your home through the ground, it then reaches that ambient temperature and you can then pump it back into your house and it'll be warmer. Then if your house is too hot, like say here in Florida, you can pump your air through the ground and cool it. If you've ever been to the beach and you're like hot, hot, hot as you walk your way down to the water, you also know that if you brush away the surface sand, it doesn't take very far for you to get to that nice cool earth. FGCU, Florida Gulf Coast University, actually uses this principle to take the water that they use in their water fountains and they pump it down into underground tanks at night, and they chill it just by using the ambient temperature of the ground, and then they pump it back up during the day. So they use no electricity to actually to chill that stuff. Pretty cool. Also realize, just as a side note, you can use, wrong direction, sorry. Come on. You can use the steam straight up to just heat your house, but you have to be close enough to it to work. Hot steam doesn't go very far, so it's not like you could have a source of it 5 miles away. If anybody has ever had a hot cup of coffee, you know that doesn't last very long. Okay, so hydrogen fuel cells. These are largely designed as an alternative to internal combustion engines for cars. It operates like a battery, but the reactants are added to it continuously. So you have oxygen in the air, and then you have a source of hydrogen. Those two things, when they are together, they will naturally combine to create water vapor, but in the act of that combination, it also creates energy. However, you need a supply of hydrogen. You can burn natural gas to extract hydrogen. You can also use a process called electrolysis to split water to create that hydrogen. You can actually do this at home with a 9-volt battery, a couple pieces of copper wiring, and 2 pencils. It's possible that we could engineer algae and bacteria to create that hydrogen gas. Please realize that when we talk about burning and electrolysis, you have to put in energy to get that hydrogen gas. So the benefits are the only byproduct you're creating is water vapor. Here are the drawbacks. How do you obtain that hydrogen without expending more energy than you're harnessing? When you talk about an EROEI, are you ending up in the hole doing this? Is this just kind of like a fun experiment that's not worth it? There's no distribution network. And then if you're transporting hydrogen, hydrogen is ridiculously flammable. If you're wondering what this is the Hindenburg. Back when we were thinking about using blimps to transport people, we used to fill them with hydrogen, and it got all exploding and stuff. Okay, so, oh, by the way, how exactly does this car move forward? The process of making that energy I'm talking about, it's specifically electrical energy. So these are electric cars. Okay, wind energy. Wind just keeps flowing. Wind energy used to be used with windmills to turn a stone that would be used to grind grain. That was its large purpose. Now we found out that you can use wind to turn a turbine, to turn a generator to create the electricity. What are the benefits? No emissions. The wind just blows. It's there. You may as well take advantage of it. It's free. This is the really cool part. Wind farms can share land with other uses. Like a cattle farmer can just erect a bunch of these things, and then they were already farming cattle. Hey, let's go ahead and have the wind turbines as well. They can be built offshore. If you've been to the beach, you know there's wind there all the time. This is another really cool part, is they can be small scale. So let's say you have a farmer in a third world country where the wind is always blowing. They can use that wind turbine as a pump to pull water out of a well to water their plants. You can then, if you combine this with a battery, you can use that wind energy to charge batteries to do all the same things that you could with solar energy. You can have one of these on top of your house and use it to create as a secondary source of energy for, to power your house. Okay, the drawbacks. Batteries for storage are expensive and hard to recycle. We're still kind of working on that part. You do have bird and bat collisions. The biggest complaint with wind farms is people don't like the way that they look and that they block their view. I know that sounds like a petty complaint, but if you are out in the middle of nowhere because you wanted to look at the mountains and then you have all of this visual clutter in front, you're like, come on, guys. What's the deal? These things do make a whoo, whoo, whoo sound as they turn. Do you realize that the caveat to this here, bird and bat collisions, they are a drop in the bucket when you compare them to something like stray cats. Also, if you are careful to not build these things in migratory pathways for birds, there are like 5 pathways from north to south in the United States, as an example, that have been mapped for centuries. Don't build a big wind farm there and you're good. Alright, so talk about energy conservation in general. Guys, the best way for us to stop using so many fossil fuels for energy is to stop using so much energy. How can we do that? There's a whole list of things right here. Here are some other ideas. Have a cooling landscape. So let's say you have those south-facing, windows. What do you do on the north side of your house? Plant a tree that drops its leaves in the wintertime. So that means in the summer, shading your house means your house doesn't get as hot. You don't have to use as much energy to cool it. And then in the wintertime, when you actually do need that sunlight to hit your house, poof, leaves are gone and you're good. Electric cars. Now again, these are actually more efficient than gasoline-fired cars. But of course, remember, you have to create that electricity in the first place in order to charge those batteries. Plus, these you have to have the mining that goes into creating the batteries in the first place. And I have no idea how long those batteries are actually good for. However, If you make that electricity from renewable resources like sun and wind, you cut down significantly on your impact on the planet, and your use of things like fossil fuels. And then also, like I said, these things are just flat out more efficient. Um, Hybrids, I've got one of these. My hybrid SUV gets 42 miles to the gallon. Kind of cool. How does that work? What a hybrid does is it has a battery, which I don't have to charge, that charges itself based on things that are already happening in your car. So as your motor is running, some of that excess energy that is not used is then used to charge the battery. The battery kicks on when you don't need the power that the combustion engine can use, um, or that is needed. So, like when I'm just driving in a constant acceleration, or I'm going at low speeds, my internal combustion engine doesn't kick on. But then for uh, things like accelerating. Well, this one does accelerating and decelerating, but I can tell you that my engine cuts on and off depending on when it's needed. So to me, this is a really great way of reducing the amount of energy that we use, because this is kind of like cogeneration in that the battery is charged by stuff my car is doing anyway. The way that you go about setting up your home can greatly reduce the amount of energy that you use. Like the new house I moved into is built primarily because it is has a very strong structure to withstand hurricane force winds. So it's got the strong windows, and it's got the thick reinforced walls, and it's single story, and it has everything about it is just made for a hurricane. The side benefit is that the thickness of the walls and the thickness of the glass and the strength of all of these materials means that it is a super insulated building, and it has greatly reduced our electrical bills. Now, if you're wondering how low flush toilets reduce energy consumption, it takes a certain amount of energy to pump water into your house. If you're wondering why rainwater collection reduces energy flow, it takes energy to power your irrigation systems, as an example. Um, uh, I don't know why a safe room would be considered to be a energy conserving thing. I guess that's just, yeah, we'll skip that part. Sorry. Um, Energy Star appliances that use less energy. Anything, the overhangs. Now, some of these are just good ideas for your health in general, like carbon monoxide alarms and stuff like that. Why minimal carpet use? First of all, you have that bare floor that's going to absorb heat and re-radiate it at night. But also, you're not buying extra stuff for your house that had to use energy down the line. So anyway, there's a lot of things here that you can look at. This is an example of a home that is using super insulation and passive solar heating. Let's go ahead and look at the super insulation part. It's built into the side of a mountain, so it is using what already is there to keep energy, to act as that thermal barrier. And then also look at the top. It's got a green roof. That means it has a low albedo. Now imagine if this was also turned into a garden, as an example. Now you've also added a source of food for the people that live there. Again, that's not technically energy saving, but then think about the energy that is saved in terms of refrigeration and going to get that food from the store, and the agricultural uses of energy if it was grown elsewhere, and then the transport especially. Now do realize that if you want a green roof like that, you have to make sure that your building is built to hold that up, because wet dirt gets real heavy. Okay, so that is the end of that. And yeah, end of the review.